So in the first few sentences, the author talks about what a language is, and I'd like to fill this in with some amount of context. So intuitively, a language is just the set of symbols that we use to make expressions and to denote certain things. In model theory, we divide these into sets of symbols for functions, relations, and constants. If you try to connect this idea to something familiar in first-order logic, of maybe a first class that you had in first-order logic, and think about sentential logic as an example, that'll actually be possible but difficult. It's much easier to make the connection to true first-order logic, where, of course, the idea of relations and constants are familiar, even if perhaps symbols are not, but you will, be familiar with having, say, a relation LXY, which in first-order logic might have been used to express X loves Y. Now, what it expresses is, of course, a semantic notion, and so technically, in some sense, I shouldn't be talking about that yet, since we're only talking about the collections of symbols, so I should only really be talking about syntactic notions, but I'm in fact going to talk about a bunch of semantic notions before I really should, just so that they connect to familiar things. So, but the syntactic part of this is just the symbols that we use in the language. It should also be familiar that we could have three-place relations. A one-place relation may or may not be a little bit new and confusing, but that's just what we call predicates. So predicates just are one-place relations. You may have seen the equality symbol, and that would be located in our set of relation symbols. Its meaning, a syntactic notion, would, depending on how what you had in your first-order logic class, you might have heard it said that the equality relation is the set of all pairs such that the left and right coordinates are the same, but whether you're familiar with that or not, and maybe it'll become familiar later on. Anyway, I've used plenty of semantic notions, so just to make sure that it's clear which are the notions that are semantic, so that you can kind of keep this separate in your mind. The notions of domain and even the notion of a relation itself, rather than the symbol that denotes the relation, the domain and the relation, those are semantic concepts. So when we're talking syntax, we really only want to talk about the symbols used to express these other things. So to talk a little bit more about how function symbols get used, in case anybody's not seen that before, if C is any constant in a language, then f of C, assuming it's a one-place function, would also be a constant. So again, veering into semantics, let's suppose that our domain is R, and let's suppose that the function symbol f denotes this function, x plus 1. In that case, if C denotes the number 2, then f of C denotes the number 3. So f of C would be a constant in the language. That's how function symbols feature in a first-order language. Now, if I wanted to write a sentence, not just express or have a symbol for this or that constant, but say something with it that could be true or false, then we could define the less than relation. Now, defining it would be a semantic thing to do, but once appropriately defined, we could then say that this sentence is true. Now, again, I've used plenty of semantic notions, and so don't be misled by that. I'm getting a little ahead of myself, but intentionally so. Okay, I'll complete this and talk about the formal definitions of these things in the next video.